Hello and welcome to Beginners Python and Machine Learning Meetup number 79. My name is Tim Cummings. Today we'll be looking at Python classes, which are a thing used to allow us to do object-oriented programming in Python. Object-oriented programming has been pretty popular. It's what the difference between C++ and C was. C doesn't do object-oriented programming, but C++ does. Similarly, Apple developed Objective-C so that they could get object-oriented programming in a C-like language. Java does object-oriented programming, and Python does as well. So today we're going to be using Google Colab. So you don't need to have Python installed on your computer, although you can use the notebook if you can do Jupyter Notebooks on your computer. If you look at the Meetup site, or even if you look at the YouTube site, which you're on at the moment, you'll see a link to a Colab notebook. And if you click on that, it will open up the notebook that I've prepared for this session. And you may need to log in to Google Colab to see it. And then you can save a copy of that onto your own drive, and you'll be able to make your own changes. So once you've saved a copy, it'll come up with a new name called Copy of Meetup 79 Classes. Now you can rename that if you want just by clicking in there. But this will save it to your account. Today I'll be following chat on the YouTube chat that's on the page that you're on, and I'll also be looking at the Learning to Code channel in Beginners Python Slack channel. So you can post any questions to either of those places. Just feel free to ask any questions that you want. This is supposed to be a series for beginner programmers, so don't feel like you need to know, that you don't want to ask a question because you feel like you should need to know something. I'm going to assume that we've had regulars here using Google Colab, so I don't need to teach you everything about Google Colab, but feel free to ask questions if you want, and because if you don't know, then I'm sure other people won't know either. So the first thing I'm going to do is I'm going to share this notebook. So you can use this link as well. So that if I type anything into the notebook, you can follow this link and you can get any changes that I've made to this one. But that other link is what you should use to get the main notebook to start with, because that won't have anything that I've incorrectly typed in or whatever. So I'll just put that onto the YouTube chat, and I'll put this into the Slack channel so you can see it in either of those places. Okay, so what's the point of object-oriented programming? One of the big problems when writing programs is that you get so much code that it becomes unmanageable. And so people are always looking for ways to break it down into smaller compartments. And one way of doing that is by using objects. So objects, you can create an object, and an object is usually just a metaphor for something that you're working with. And you'll see some examples as we go through. With that object, you can store all your particular data that's related to that object. You can store functions that define the way an object behaves. And in fact, in Python, everything is an object. All the different data types that you've used already, like your ints and your floats and strings, are all objects. So, but the real power is when you can start to create your own objects as well. Put a couple of references here. Is a reference to classes on the Python tutorial, and there's also a reference to basic customization. And that basic customization is about specific things that you can do to your objects that make them work well in the Python world. Okay, so let's get started. Today we're going to be using the standard libraries datetime and pretty print. So I'll select that Google Colab cell, press Shift Enter and run that. So then throughout this session we can use those libraries. Now the very first library you try to run will be quite slow. So the very first cell you try to run will be quite slow. But once it's done that, then the others should be a bit faster after that. Now we can create new cells. So if I'm on a Mac, so if I do Command M and then A, it creates a new cell above. You can do the same thing. You create a cell below, Control M and B, or Command M and B does below and A does above. I've already told you that other data types are already objects. So let's just take a number 1, 2, 3. Let's have a look at the type of it, and it tells us that it's an int. Okay, so and if I print that, it tells me it's of class int. So you can see integers are types. The same we'll have with floating point numbers and strings. So you can see they're all classes. So let's have a look at what we can do with a class. I've chosen to use the built-in class complex because it's a little bit more interesting than the ints, floats and strings. So we can create a complex number just by putting two numbers with a plus between them and a j after one of the numbers. So let's 3 plus 4j, we'll store that in the variable c, and we'll see what we get out. So c is 3 plus 4j, the type of c is class complex, and the representation of c is 3 plus 4j. Now if we've got a variable with that is an object, and we want to see if it's an instance of a particular sort of object, we can use the built-in function isInstance. So if we want to see if C is a complex, we run isInstance C, complex, and the answer comes out to true. Now I've used format string here to do this, so it looks a lot better when you're running it, maybe not in Google Colab. If you want to do some of these things in Google Colab, you can just type them straight in. So I'm going to create a cell above. There it is. And if I can just type isInstance C, complex. So that's the crux of what this next line is doing, and it tells us true. But by putting in this extra print statement, I'm giving you a little bit more detail about what's going on. Right, now C has attributes real and imag, and that's because it's an object. We can access those attributes using dot notation. So C dot real and C dot imag is how we see those attributes, and if we can see what they are, if I run that, then C dot real is 3.0 and C dot imag is the imaginary number, it's 4.0. So they're both floating point numbers. And we access them by using this dot notation. People who come from the JavaScript world will like the dot notation. They like to use that with their JavaScript objects. Objects can also have functions attached to them. And when you attach a function to an object, it's called a method. And you call that method by using the dot notation as well. So for example, complex numbers have a conjugate method. So we can say c.conjugate, which says, tell me what the conjugate value is of your value, which will return another complex number. So in this case, the conjugate of 3 plus 4j is 3 minus 4j. Now, to create objects, say we've defined a class, we would normally create it using the class name and then parentheses and then any arguments that we might need. Now, because complexes are built-in one, they're able to do clever things and just create it by checking for a plus sign and a j, or a minus sign and a j, and then they can give us a complex number. But we can also use the standard non-built-in way of creating these classes. So the class name is complex and the arguments are the real and the imaginary part. So let's create a new complex number C2 using this way of instantiating it rather than 3 plus 4j, and then we'll compare it to our other value C. So let's run this cell. So C got created, it was 3 plus 4j. C2 got created as 3 plus 4j. And if we use the equals operator, it checks and it says, yep, the real parts are the same and the imaginary parts are the same, therefore it returns true. Okay, so let's get on to creating our first class. And we use the class keyword to do that. And then we give the class a name. So I'm going to call this class my simple class. And the convention is to use title case for class names. So that just means every word starts with a capital letter and we don't have any underscores in the name. So you can actually tell with Python classes, some of the ones that have been around a long time, like complex, they start with lowercase characters, and I think that's just because it's been around so long before they actually came up with this convention to use title case for class names. Now, this class is going to be so simple, it's not going to have anything in it, but the class definition, it ends in a colon there, so we've got to put something there. So what we do is we put in the word pass, which is really a do nothing in Python. So by pressing Shift Enter on that cell, I've now defined a class. Now I can create an instance of that class. I'm going to call it MSC instance, just by using the class name and parentheses. So that's being created. Now I can set attributes on that instance. So I just say MSC underscore instance, and I use the dot notation to set an attribute, and I'm going to set it with this string, which is going to be value A. And some people will actually create a class just like this. That's all it does, pass, and it's just a place that they can store attributes. And then they can come back and get them later when they need to. So let's have a look at how we get the value back out. So MSC underscore instance.a gives us value A. In this print string, I wanted to see how it was represented, so I put the exclamation mark R at the end, and that's the same as if I enclose the whole lot in REPR function. And so the REPR of MSC instance.a is the string value A. That's what we'd expect. Now say we wanted to create our own class of complex that did much the same thing as the built-in class of complex would do. So we've got to do a few things here. We've got to create a way that the class can be instantiated with and take the parameters real and imaginary. Now in Python there's a special function name called underscore underscore init underscore underscore that takes real and imaginary parameters. And also any of these methods that we put into a class will start with a first parameter and we'll call it self. Now, it doesn't have to be called self, but by calling it self, you'll be in line with every other Python programmer, and so people will be able to understand what you're talking about. So this function, which we call dunder init, because double underscore on either end, it takes these parameters and it can store them in attributes. So self.real. So self is referring to the object itself, the instantiated object, and it just stores it just as we said MSC instance.a equals and a value. Here we're saying self.real equals and a value. So those names don't need to match, but this name here and this name here, they're the ones that people will be referring to later. So you need to get them right. Now I'm going to define a method here called conjugate, and that just creates a new object and the same real number and the negative of the imaginary number. And I'm also going to provide this method here, dunder string, and what that means is by defining this, whenever someone tries to print out my function, or they put they enclose it in str and convert it to a string, this is what they'll get out. And so let's have a look at what we get. So to define, we've defined the class. Now we can call the class to create an instance of the class. We'll put it in D, and then we'll print out what the value of D is, which will use the string method, and we'll do the conjugate. So it'll call the conjugate of that, and then the conjugate will call its own string method. So let's see what we get. And because I didn't press shift enter on this, I didn't define the class. So that's now defined, and now I can run this. And it says the conjugate of 5 plus 12j is 5 minus 12j. And you can see to do the string, I had to check, I had to do this inline if statement to decide whether I'm going to put a plus or nothing before the imaginary value. Because if the imaginary value is negative, it will provide its own minus sign, but if it's positive, it won't provide it. So in that case, I have to provide a plus when I'm printing. So please ask questions if you're not understanding any of this. Otherwise, I'll just keep powering on. So if you want to find the attributes of D, which is the instance of complex, we can use this dunder value here, dunder property dict. And it says the attributes are real and imaginary, and that one's got a value 5, and that one's got the value 12. You can also call dict on the whole class complex, and that gives us all of these things. So you can see real and imag are not part of the class, they're only part of the instance, they're instance variables, but conjugate was defined in the class, and so it's comes up in complex.dict. So when you call something in a class, it first looks at the instance. If it's not there, it goes to the class and sees if it can find it there. Okay, so here's our first task. You can just watch me solve these tasks as you go through, or sometimes I suggest you pause the video at this stage and try to work it out yourself, and then you can play back, press play and maybe play it at double speed so you can catch up to where we are and see how you went. So we're going to create a class Invoice. So to do that, we use the keyword class, the name of the class, Invoice, and then a colon. Then it's got to take parameters when we construct it. So we define our constructor, which is always called init. And that will always start with the self parameter. And then it takes the parameters that we want. AUD amount, days terms, and date document. a colon for the end of the function definition name, and then we do the function itself. So let's just save them in attributes that have the same names as the function arguments. Okay, so that's done the constructor, and in fact that's all we need to do. That actually satisfies the task. So I can press Shift Enter and it's done. Now if I look at the solution, we've done the same thing. What have we done here? We've got the parameters here. I've put in a couple of default values. So the amount gets saved here. The day's terms will default to 30 if it doesn't get provided. The date of the document will put in today's date if it doesn't get provided. Now I've also given a method to this called dateDue, and that's going to calculate, it's going to look at the date of the document, being the invoice date, and add the number of days of the terms and calculate what day the invoice is due. I've also shown you how to put documentation in for your classes. So this string here, it's enclosed in double quotes, that's your doc string. So at any stage you can do help on this class and it'll return this doc string. I've also put doc strings in on each of the functions in the class, and it's always a good idea to do doc strings. They can really make it easier later when you're trying to work out how to use stuff you've written, and when other people are as well. So then we're going to create a new invoice with an amount of $350, and I'm going to use default values for days, terms, and date document. And then I'm going to print out all the attributes of that invoice. So solution 1, invoice for $350, dated 29th of September, which is today's date, is due 29th of October 2020, which is in 30 days' time. Right, now when we're calling a method, one of these methods on an object, there's two ways we can do it. You can do it using the dot notation that you've seen here, so iv.dateDue, which is like that, or we can call it by using the class name, then the function name, and then pass it, first parameter being the object that we're calling that method on. And in fact, that's what Python's doing. If we do that, that is just a shortcut for this. And that is why every one of these functions needs to catch that parameter self, and that it stores in the variable self, and then you can use self on any of the things in this, any of the lines of code in that function. So let's test that that works. And yes, it came up with the same value for date due in both cases. All right, so we want to, task 2 is to add a string method to that class so that it's easier to print the invoice. So I'm going to define, and normally you do this straight in the class. I don't want to have to write the whole class out again, so I'm just going to take a bit of a shortcut. It may be a little bit hard to read, but it's what I'll do here, I'll create the function outside the class and then I'll insert it into the class. So the function's going to take self, and it's going to, what do I want to do? I want to return a string, and so the string is going to be something pretty much like this. So it's just going to say invoice for self.aud amount dated and is due then. So you can see I've used the date time library string format time to give it a day, month in letters, and a 4-digit year. So that creates the function. Then I can insert that into the class by assigning it to this class value. Okay, and then I'll test it works. IV, oh, there we go. I'll just do string of IV. So that's what we're looking for. And that works. Now, right at the very bottom of this notebook, I've put the classes defined without using this trick, so you can see how you would normally type them in. But this is how you do it, just by inserting it at a later stage. Not a really common thing that you would do with a class. Normally you define the class right up front. But because we're in a Google Colab notebooks, we can, and we don't want to have enormous cells of code copying and pasting, that's what I've done it here. Okay, let's look at our solution. Pretty similar. I used a different name for the function, but that didn't matter. I just used that new name when assigning it to invoice.dunderstring. And I got the same answer. Now, some people have heard of Lambda in functions, in replacing functions. Lambda is a way of doing a one-line function. So if you wanted to do the same thing using Lambda, that's how you would do it. So Lambda replaces the defining this and then putting it in here. You can just put the whole lot down there. When you say Lambda, you have to say what your parameter is going to be, then a colon, and then the function that's based on that parameter. You can have more than one parameter there, but it all has to be returned in one line. So if you can do the function in one line, you can use Lambda, or you can use define function. There's no benefit either way. It's just if you think the code's more easy to read with using Lambda, then do that. Let's see if Lambda worked. Yes. And I used a different format just to prove that it wasn't just the previous version that was working. So that just used a 3-digit month, 3-letter month by using lowercase b there. All right. Hope you guys are following along okay. So the next thing we're going to do is we're going to create a class for quote, which works pretty much the same way as invoice, and it has values for amount and days valid and date quote and a method for when it's going to be valid too. So I think, oh yes, I've written something that does pretty much that, so I'm just going to copy and paste it. So we'll call it quote. I won't worry about docstrings for the moment. It's got an amount. Rather than days terms, we'll call it days valid. We'll let it be valid for 60 days. And date document, which we'll keep using date document, and a method date valid too. Okay. Date valid too. All right. Let's see if that works. Q. Oh, we'll put a string function in as well. so we can test it. We'll create our quote, $123, and then we'll just look at it. Yep. So that's when you do this in IPython, you get the REPR of the value, but we'll convert it to a string. Quote for $123, dated today, due 20th of November, which is 60 days. So that's good. That worked. Okay, but we did a lot of copying and pasting of code to get that. And whenever you're copying and pasting code, you think, all right, I'm doing something wrong, because it's really a bad idea, mainly because when you discover a bug in the original code that you copied from, you've then got to find every place you've copied it to and fix the bug there as well. So object-oriented programming solves this problem by using inheritance. What you do is you create a base class for the document, for your class, for your object that's got everything that's the same, and then you just change the bits that are different. So this solution here is doing the same thing but using inheritance. So it's created a document class, and then it's created an invoice subclass and a quote subclass, which are based on our document base class. So the document base class has got your constructor, it's got a method called dateDuration, and it's got a string function. Now the string function, we've put it into the base class in this case, which means we need to know a little bit more information about the subclasses. So we need to know what the document type is, whether it's an invoice or a quote. And you remember in our string we had something like is due, in fact I got that wrong, that should be is valid to, because is due was for the invoice, is valid to, and for the invoice it's is due. So we'll call that the action, and we'll call that the doc type. So we'll store the doc type and the action, and then the other three amounts. Days duration, we don't know whether that's days terms or days valid to. And we'll store them as attributes of the base class. The duration calculation will be based on the document class, the date of the document. Well, it's the same formula that we were using every time, just do different names. And then in the subclasses, we call this superclass by using this super function that we want to then call the init method, the constructor of that. We pass in and we're saying this time it's an invoice, and the payment due is our action, and we've got an amount. We pass days terms for the days duration, and date document is the same. And quote's pretty much the same. And we run it, and that works. Solution 3 with inheritance. We've got a quote, $346, dated 29th of September, valid until the 13th of October. Oh, we've chosen a default number of days of 14. All right, so task 4, create a sales order class, which is a days deliver when the goods need to be delivered. Once again, this is going to be pretty similar. I will copy and paste, but I'm really copying and pasting the structure because hardly any of it's going to be the same. We'll call it sales order of document. We've got the amount, days deliver. So we want it to, so when someone's ordered something from us, we have to deliver it in 7 days. We'll give it a name, sales order. Deliver by list date deliver. So let's look at the solution. It looks the same. Yep, and I put a test here in the solution, so it saves me having to do it again. I'll run that. Sales order for $1,234 and delivered by the 6th of October. So you can see that creating the sales order document was a lot easier than creating our original invoice document, invoice class. So yeah, that's just the power of inheritance that we're using there to make it much easier to create these subclasses. All right, let's create a class item which can represent a line item on a quote, sales order, or invoice. So it needs a description, a quantity, and a unit price. So to do that, should be getting pretty comfortable with creating classes now. We have the class name, item. Then we define a constructor that always starts off with self, and then the names of our parameters. So we're going to call them description, quantity, and AUD unit sell price. And we'll store them in attributes with the same names. Okay, and that's it. Is there anything, didn't ask us to do anything else? No. But in my solution, I've decided to do a couple of extra things. I've decided to create a method that would tell me what the extended sell price is, which is basically just the quantity times the unit price. And I'm also going to have a string function so it's easy to print out an item and get all that information, the description, the quantity, the unit sell price, and the extended sell price. I've also created a class attribute here. So you can see this one, it's not created here with self dot in here because that's all inside a function which has got self as an argument. This one's created at the class level, and so it's just a constant in that class, and it's just got a title for our table of description, quantity, unit price, and price. So I haven't done any examples here, but we'll see how it goes later on. I've also decided to create a method add item that I'm going to do on the document. So you see here document class.add item, and I'm just going to put this function, which for now I've called document add item. And I'm going to have a list of items and just append each one of these items to that list. Now, the first time I run this, I have to check that whether list items has been initialized because document doesn't have this in its constructor, anything about list items. So normally that's where you would put it, in list items. But just because I don't have to rewrite the whole constructor here, I've just decided to do a check, and if it hasn't got the attribute, then I'll create an empty list and then start appending to it, and then put that there. So let's execute that. So that's all defined our item class, and now try it out. So I've got my quote, Q, and I can add items. So Q, remember, it was a quote we created that extended the document base class. Document base class now has this extra method called add item. So now I can call add item on my quote and add these new items that I've created, that I've given a description, a quantity, and a unit price to. And so when I run that, I print out the string title, item.string title, and that gives me a nice looking heading across here. And then all lined up, I then just print each of the items, and it runs the string function on each one of those. It puts the description here, the quantity, the unit price, and the extended price. So this is a function I've retrospectively added to my document-based class, and it's been inherited by all the classes that used it. Okay, so task 6. Now I want to create a report in document for all the documents. What I mean by this is we've got our string function, but it just gives us a summary on one line of the document that we're talking about. But really, we want to be printing out quotes, printing out sales invoices, sales orders, or printing out invoices, which is going to have all the information. So if I defined a function called report, and we're going to put it in, I could do it on the document, I guess. So what am I going to do? I'm going to return a string. It's going to return a string. I could have done a print, but I'll do a print for this one. So we're going to do just things like I'm going to put an F out the front there. Self dot the date of the document, and then I'll format that. And we had a in document I had a date format, so I can refer to that as self.date format, and it won't find it as an instantiated, one of the instance attributes, but it will find it as a class attribute. So let's just use that self.date format. There it is. Then we'll do all the items. String title for item in self.list items. I don't need anything else around that, so that'll do that. And what we're going to do is we're going to have the initial amount that's provided is going to be extra charges, and then each item is going to have its own charges as well. So that can be self.aud amount. We'll print a subtotal here. Which will calculate using that method. and then the total. Okay, we'll insert that into the document, base class, so that we can call it, and then we'll try running q.report. There we go. So the document came out as a quote, date the 29th of September. I forgot to put in the valid to date, but I did that in the solution, so we can do that. Look at that. We've got a nice little table here of the items. We've got the subtotal, the extra charges, and what the total is. So that's a fairly good report we got from a fairly small amount of code. Here's like a little bit more code, but this is all nicely formatted. I've also, on the items, I've put item numbers down the left-hand side. So I've assigned it to the report, and then this one returns a string so that we can do what we want with the string. We can convert it to a PDF, or we can print it out, that sort of thing. And it's all nicely right justified as well, so all the numbers line up. And I'll put the valid until date in there. All right, now I was going to print out iv.report here, but then I remember we created iv before we created document, so that probably won't work. In fact, let's run it and see what happens. Yep, Invoice doesn't have the attribute report. So because iv was created before Invoice inherited from document, so it was a different definition of Invoice, then it doesn't have that report function that quote now does. And we can check what the inheritance is using isInstance. So I've just done a couple of loops here that we're going to loop through our quote that we created, our sales order that we created, and our invoice that we created, and see whether they're instances of document, of quote, of sales order, and of invoice. So here's our quote. That's our one-line summary. It's inherited from true, so when it's an instance of quote, but it's also an instance of document because it's inherited from document. Sales order is an instance of sales order and document, but not of quote and not of invoice. Invoice, which is our really old one, is not even an instance of the new value of invoice. It's an instance of the old definition of invoice. So it doesn't even come up true for invoice there. So to test it for invoice, we'll just create a new one. iv2 equals invoice 15. We'll add the same couple of items to it and have a look at what our invoice report looks like. Invoice payment due, that all looks good. Right, now you see what we've done by changing invoice to now inherit from document. We no longer have a way that someone can look at the day's terms of the invoice. They have to know that the name has changed to date duration. So if I did iv.days terms, so that's the original, using the original definition of invoice, I can do that. But if I try that on iv2, it doesn't work. So what we've done here, this is what we call when people say they've changed the API. So we've changed it from the old system to the new, and it breaks code that expects that to happen. So task 7 is to add a method back to invoice so that users can still check the value of days terms without having to know the name of the subclass date duration. All right. So let's define our function days terms, and all it has to do is return date duration. Ah yes, and I've got to put that into Invoice. Okay, let's print it out, see what we're getting. Oh, I've used date duration. That should be days duration. And so now it prints out 30. So that's what task 7 asked us to do. It didn't actually solve the problem totally, because people using this now have to know that it's days terms a function or a method, not days terms a property or an attribute. So in this provided solution here, I've shown you how you can actually make a function behave like an attribute, and it's called a property. So we use this at symbol, at property, before when we define the function, and that just says that it's going to be callable. It converts this function into a way that it will be callable just by using the name of the function without the parentheses at the end. And so that way people won't even need to know that the name has changed. It started as days terms an attribute, it became days duration as an attribute, or days terms as a function, but now we're actually letting them use the old API, which is as though it's an attribute, because we've converted it into what's called a property. So there you go, that works. iv2.daysTerms, and it returns the value 30. Now the problem with this is that we can't assign a value using the attribute notation like we could in the past. But we're pretty close. So that threw an error, an attribute error, and the attribute error was can't set that attribute because it's a property, and that's a read-only property. Now sometimes that's what you want. You want a read-only property. You don't want someone going in there and changing things after the object's been created. But yeah, that's just on a case-by-case basis. So let's try doing the same thing for days valid. For quotes. So we define our function, we return the same value, days duration, because that's what it is for quotes. We add the decorator to make it a property, and we assign it to the class for the quote. And then we'll test it. q.days valid 14. So that worked. Now in the solution, we've done the same thing. We've got at property, days valid, but we've also used this other decorator, days valid dot setter, which now means that we can use it. We can, as using the attribute notation, we can set values for it. So q.days valid equals 21. So if I run that, in this solution, now we can use the attribute notation for setting and getting. And you can see that worked. So you can see property is always the name there, setter is always the name there, but this name here is the name of the property that you want to be able to set. Okay, so how are you following all this stuff so far? This is it's quite a lot that I've gone through here. I hope you can see the advantage of having these classes, and that you can put all your business logic together with the classes that depend on that business logic. That's in the way the methods and the data is stored. See the power of inheritance for meaning you don't have to repeat code when you're defining your classes and being able to use it in different places. And some of the strength of properties. One thing that I showed you how to use the dunder string function in a class. There's a whole bunch more of functions like that you can define different capabilities of your class, and that was that reference that I told you right at the beginning. So for example, you could set a dunder LT method, and that tells you how to compare two objects of the same class. So it's LT GT for greater than, LT for less than. You also do less than or equal. You can also do EQ for equals. And you define all those methods, and then you can start to sort objects of your class because you've defined how they will behave in a sorting mechanism. So now we're going to go on to some probably a little bit more advanced stuff to do with classes. So this is stuff that you're not going to come across every day. I wish there were coloured lines to show where everything comes from when dealing with classes. Yes, yes. So in fact, we'll see here I'm about to do an exercise with classes and subclasses, and we're going to try to see where the stuff does come from. So I've created a class called myBase, and I've created some class variables in that myBase. I've got my1, and I've got my1 with an underscore, my1 with two underscores, and then my2 with an underscore, my2 with two underscores. So what the underscores, if you don't put an underscore, you're pretty much telling everyone this is a public class variable. Feel free to access it whenever you want, get the data out of it, maybe even set it. If you put an underscore there, you're saying, don't use this one. People will still see it's there, but you're warning them. You're saying, this is probably a private one. This is private. I don't want you using it because I think I might change it, just like we changed days terms to be just days duration later on when we changed the class structure. So putting an underscore there tells them that it's going to be private. Putting a double underscore there is telling them, still telling them it's wanting to be private, but it also is a way of protecting the values in superclasses, so you can still refer to the superclass values. This is a little bit complicated. I wasn't even sure of it myself, exactly how it worked, but by building this class, I can now see how it all works, and it could be useful. You might come up with some scenarios where it's useful. So my1 is only declared as a class variable, so it's not going to have self.my1 in any of these functions that set it. I've used it here for retrieving data out of it. My2 I'm going to set as a class variable, and then I'm going to override it as an instance variable, and then class 3 I'm only going to set it as an instance variable. And so the instance, when I do create it with a string, I just put that string into the instance variable value, so you can see that it's different. These are all constants for the whole class. these ones will change for every instance that we create. This creates the string forwards, this is the string backwards, just for a bit of variety. And I've got dunder, meaning double underscore one. I've called this function, and that just looks at self, double underscore my1, my2, my3, and sunder for single underscore my2. Okay, so the challenge here is really to run this code and try to predict what the values are going to be in all the output. So I'll just run it. And here we've got, so my instance dot my1, what am I going to get? And the string that I get back is my public class variable. So it's gone back to the class value because it was never set in the instance. And so that'll be the same. I can also call the same value by using the class name and then dot my1, and that also returns the same thing. So for the my1s, the class and the instance calling of the attribute return the same value. Same for the single underscore my1s. And then this is a bit of a surprise. The double underscore my1s, what has happened here? My base object has no attribute my1, but you saw that we created an attribute double underscore my1. Why can't the instance or the class see that value? And the reason is that Python does a thing called name mangling. So if you start, it's a fairly complicated rule, if you start your variable name with 2 underscores and you finish it with at most 1 underscore or 0 underscores, then it changes its name to put the class name in there. So double underscore my1 becomes single underscore my base double underscore my1. So if we use that as the name of the attribute, then we can see what the value of the class variable is in both cases. And it's the same for when we call it through the instance or through the class. So try to think of what's going on here. I'm calling this one through the, now let's look at my2. We're calling it through the instance and through the class. So the class should give me the class variable, the instance should give me the instance variable, and now they should be different because these my2s were all defined in the init function, in the constructor. So public instance variable BPAML, because I created this using my string BPAML for beginners Python and machine learning. And the class has got my class defined the same way as my1. So they're different now because the self overrode it for the instance but not for the class variables. Similarly for single underscore my2, double underscore my2, we're seeing the same thing happening. The name's been mangled so it doesn't think it's got that attribute. All right, so yes, we're definitely here trying to fry your brain. So, but we can refer to it using single underscore my base, double underscore my2. And the reason they do this name mangling is because sometimes you want to be able to, when you've got code in the base class, you want to be able to still refer to the variable as it was defined in the original base class, not as it is now defined in the subclass. And so by putting the class name here, we've got, we can know which class it's come from. But we'll see later where we would do that. Okay, my3, it was only defined in the init, so mybase.my3 doesn't give us anything because there is no class variable, it's just an instance variable. So for those 3, there is no, and even in the mybase double underscore, there's no attribute. So there's no attribute in any of those cases, but for the instance variable there is. We've got our instance variable, the private instance variable we can still refer to. The double underscore, same thing's happening. There's no attribute with exactly that name, but there is an attribute with the name single underscore mybase double underscore my3. And here we've called the functions. So remember dunder1. Let's have a look at dunder1. It's calling self.double underscore my1, Now remember, that doesn't work when we were calling it outside the class, but now we're calling it inside the class. It does work, and that's because the name mangling works all within the class. So anywhere that Python sees a double underscore variable name, it mangles the name so that they're all referring to the same thing. Now, if you happen to use another variable name that is made up by that same way that the mangling happens, you'll really confuse things. So don't do that. But yeah, dunder1, that now works. It refers to the class variable. Dunder2 refers to the instance variable. Dunder3 refers to instance variable, and sunder for single underscore 2 refers to the private instance variable. No surprises there. And in fact, this is, if you didn't, you might not even know name mangling was happening, and these would all behave just as as they have. So that's why a lot of people don't even know that this name mangling happens. All right, so now our next situation is we're going to subclass my base with a class called my sub. And yep, I've created my 1, my 2, my 3. My 1's just in the class, my 2's in the class and in the init, and my 3 is just in the init. I've used the here rather than my, so I can know whether it's come from base class or subclass. So the subclass has the, and the base class has my. So the subclass calls super on the init, and it's going to send the string subclass to it. And then what's it going to do here? It's going to call super on my 2, super on underscore my 2, and it's going to try to do the same thing with the double underscores. I've put a try except here because I know it's not going to work, and it's going to print out an error if it doesn't work, because that would have to do the name mangling if it wanted to do it properly. Okay, so we'll create my sub using our string inheritance and see what we get. So I'm going to run this cell. These are the same, my 1, sub, so these are all come from the subclass. Double underscore, once again, can't find it. But now you see for the double underscore my 1s, we can refer to single underscore my base my 1 and get the value from the base class, or we can refer to single underscore my sub my 1 and get the value from the subclass. So we get that from the superclass or from the subclass. In fact, you'll look down here, all of these have got the in them, except for the ones where the double underscore values that are name mangled to use my base. So they're the only times we're able to get it out. We're able to get it out with the methods as well, because the name mangling has happened within the methods. All right, no more surprises. So in instance class, we've talked about them. And once again, instance, there is no class for my 3, there never was. And same for those 3. And so they're all the same. Now, are there any questions about any of that? I really recommend running through that exercise and trying to predict yourself what you're going to see in each one of those cases, or even just trying to explain why it's happened. Okay, so another thing you can do in Python that you can't do in a lot of object-oriented languages is multiple inheritance. So you can have a subclass that is based on 2 base classes. So for example, we can create my complex sub as a class that is based on complex, which we defined earlier, and my base. So to do that, these subclasses, these base classes, weren't designed to be used in a multiple inheritance situation. So we can still use them. It just means that we have to call super on every one of the super classes. So we call super, and that'll take us to complex, and then we can call super, and if we specify complex here, it'll take us to the next super after it's got past complex, which in this case will be my base. So if you add more along there, then you do a super my base, self, and run the init on each one of those. So we're going to run init for the real and imaginary parts, and then we're going to take the string of our complex value and run init in my base on that. And we're going to have a look at my 1, my 2, my 3 and see what we get. So when we print my, it finds the string method of complex, which is just gives us our 5 plus 12j, our complex number. We can look at the attribute my1, and that gives us the class variable. My2 gives us an instance variable. My3 gives us an instance variable with the complex number reversed. So that's the complex number going forward, and that's the complex number reversed. Now the other thing that I've printed out here is this dunder MRO, which is the method resolution order. So when it's trying to find a method, it starts looking in my complex sub. If it can't find it there, it'll look in complex. If it can't find it there, it'll look for it in my base. And if it can't find it there, it'll actually look in object. So every class that you create, if you don't define a superclass for it, it will use object as the superclass. And so there's the method resolution order. Right, so how do you design base classes to make use in multiple inheritance easier? And the trick is, when you create your init method, you always use keyword arguments, and you pass through any unused keyword arguments to super. And if you do that, then when you call super on one class, it'll keep finding, just like super from complex will find my base in this class. So if you put a super in complex, even though complex doesn't know anything about my base when it was defined, if you call super within it and it knows it's being defined in this subclass that's using multiple inheritance, the super will go off to my base, and that's a clever thing that Python uses. And we'll see that here in practice. So to define with keyword arguments, we just say ** keyword arguments, and that'll give us a dictionary of all the arguments. The problem with this is we don't see what arguments are required, but if you do your doc strings properly, then that will people will know then what keyword arguments to use, and it passes it off to super. This one here, key 1, base 0 wants to use key 1 as an argument because it's going to use it and save it here in self.key1, but anything else is going to be in keyword arguments. And so this keyword arguments is really all the keyword arguments that got passed here except for key 1, because key 1's been put into that specific argument. Similarly for sub 2, and here's sub 3, which is based on sub 1 and sub 2, each of which is based on base 0. So I put print statements whenever an init is called, so we can see what's going to happen. I'm going to call sub 3 with keyword arguments throughout. So remember, you can't use position arguments when you're doing this way. You have to use keyword arguments, but I reckon that's a great idea anyway, so that's no great loss. And we run that. And we can see sub 3 gets called with the arguments key 2 is 2 and key 1 is 1. And then it calls sub1.init with key 2 equals 2. And so that's this one up here. And that's because key 1's already been taken out. And then that calls sub2 and there's none left. And that goes to base 0 with nothing. And then that calls object. But we didn't have a print statement in object, so you're not seeing that. But object is the next one on the list. Similarly, I can change the behavior of this subclass by changing the order in which the base classes are multiply inherited from. And that way I get the arguments get passed through in a different way. And there are cases where I've seen people write some clever code that setting that order can change the behavior in a way that they want, and makes it a really useful subclass. But you probably won't be doing that much, but it's good to know that it exists. All right, so now the last bit here is just all the full class definitions, as I said, with all the documentation in there, and this is how you would normally define your classes rather than adding in the functions on a step-by-step basis. You put them all in there at once when you create it. And so that's all there for your perusal. So are there any questions on any of that? I'll just show you now. I'll take you to that reference. So these are the double underscore methods that you can override to set the behavior. So we've seen how to override double underscore init. I don't think you'd ever want to override double underscore new, but it's there in case you do. Delete, that will help you if someone calls the delete keyword on your object, then it will run this function and delete in an organized manner so that it's not random. You've got control over it. REPR is a good one. People often call REPR the REPR built-in function, and if you provide a method, then it will return what you provide, and usually provide it in such a way that it tells people how to construct that object with that data in it. String we used, you've got format, here's your less than equal, equal, not equal, greater than equal, which are your comparison methods, so that then your object can be used with less thans or less than or equals in different conditional cases like if statements or while statements, or they can be sorted. You get a hash key. If you implement that, then you're able to use your object as a key in a dictionary. Bool testing, so that if you want to just use it in an if statement without a conditional operator, you can just, so like an empty string will be the same as false, that sort of thing. So there's a bunch of them. Oh, dir is a good one. Even dir by itself, I should have an example of dir. Let's go to the bottom. I'm in the wrong one. Let's go to the bottom of this one. I'll define those classes, and now if I do a dir of invoice, it tells me all the things that are in there that I can use. So I can even do a dir of object. So even though I didn't define all of these, some of them were inherited from object. And you can see these are the ones that are in object to start with. So if I don't define them, it'll just use the one that comes from object or from document. Okay, well, I hope you enjoyed that. That's the end of my session for today. Next week is the first week of the month, so we're just going to go back to Python for absolute beginners. So we'll just be doing a bit of variables and data types and maybe a little bit of looping. But really it's for people who've never seen Python before, even people who've never programmed before. And so feel free to ask any questions you want. You can ask any questions you like here tonight, because most people are novice who are watching this. I've done some pretty complicated stuff tonight. A lot of it, especially that stuff at the end, is just so you have to be aware of it, that it exists. Don't think that you have to remember all of that stuff. But certainly the defining classes and setting attributes that we did at the beginning, that's all something that you should know, and is very useful if you want to do object-oriented programming. If you come up with any ideas of things that you want us to cover in these courses, let us know. I'll show you in GitHub, we do a session summary of all of these courses. They'll be there at AnyQuasar session summaries, and in the TCB folder, that's where we've put the last ones, because we were doing some sessions at the TC Burn building, the latest ones we've been doing. And if you look in there, there's all the meetups up to 75. The last few aren't in there yet, but we'll be putting them in. I like to put them in as Python files, so you can run them straight in Python. You don't need a Jupyter Notebooks to do them. These ones by Arun, he does notebooks all the time, so and he does more the machine learning stuff, so notebooks make a lot more sense for him. Okay, I hope you learned something, and I'll see you next week. Arun will be the week after. Thank you very much.